Okay, the question we're dealing with today, how can you identify and classify polygons? Well, how can you identify and classify anything? Polygons are what? I'm hoping that you said something in that pause. So poly means many and gon means angle. So many angles. Some examples of polygons right here. We have a triangle, a quadrilateral, a pentagon, a hexagon. How do we classify these? What makes a triangle different from a quadrilateral? Well, tri means three, and angle, of course, obvious, angle. So it's a figure with three angles. You can see that GoMath wants us to classify these things by noticing their sides, their angles, and their vertices. So a triangle has three sides. Well, in order to have three sides and be a closed figure, then those sides have to join together. One end isn't open. And where they join together, they form angles. And those angles right there, that's the vertex. More than one vertex, vertices. So it's got three sides, three angles, and then it has three vertices. So quadrilateral, quadra, that's the four part. Quadra means four. Lateral, como lado, means side. Four sides. You can see that this trapezoid is being called a quadrilateral. There are other quadrilaterals. This one is shaped like a trapezoid. So it's got four sides, four angles, four vertices. The pentagon, five sides. 1, 2, 3, and then 4 and 5. Okay, how many angles? Well, I'm seeing 1, 2, 3, 4, 5 angles. If you have five sides joined together, you've got 5 angles. And right there where they join together, that's the vertex. More than one vertex, vertices. Hexagon, how many sides? Well, if we follow the pattern here, obviously it's 6. And if it's got 6 sides joined together, it's got 6 angles and 6 vertices. The next section, still polygons. We have a heptagon, an octagon, a nonagon, and a decagon. Heptagon is hard to remember, but it does mean 7. Octagon, like octopus, 8. Nonagon, that's like saying a 9-agon. That means it's got 9 sides, 9 angles, 9 vertices. Decagon, there's that DEC that we see all the time, like decimals, like deca, like DS. Okay, decagon must have how many sides then? 10. And if it's got 10 sides, it's got how many angles? 10. And if those angles are all there and we count them, we would say, oh, the vertex where they join, where the two lines join to form the angle, that's the vertex. It's got 10 vertices. So the blank is the repeated polygon in the Castle del Monte because it has blank sides, blank angles, and blank vertices. What is that relating to? That's relating to this crazy picture. This is a real place, and you can look it up. It is super cool, and it's wanting you to notice the shape of each of the pieces. And you'll see that this shape, and you can see the inner ring there is probably the easiest place to count. And then this shape is repeated around. And you'll notice that where it repeats the smaller version, it's right at the vertex. Interesting. Of all the things we do in 5th grade, I would say geometry is my favorite. Well, fractions. Geometry and fractions are my favorite. So looking at these words, regular polygons. When line segments have the same length or when angles have the same measure, they are congruent. Congruent means they are the same. 2 polygons are congruent when they have the same size and the same shape. In a regular polygon, all sides are congruent, and all angles are congruent. So let's look at this. We have two five-sided shapes here, right? What would that be called? Pentagon? Okay. This one, every side is 4 centimeters. Every angle is 108 degrees. Every angle is an obtuse angle. Remember, an angle greater than 90 degrees. Every angle is an obtuse angle. Every angle is 108 degrees. They are congruent. If you look at this one, oh, this side is the same as this side. So they put a little tick mark there, didn't they? That's to show you that this side and this side are the same. Just as the double tick and the double tick, those two are the same. This one doesn't match this one or this one. Here it's showing we've got the same obtuse angle. If we measured it with our protractors, that would be exactly the same here, just as these two would match each other. But notice how there's only one arc, and over here there are two arcs. The ones that each have one arc match each other, and the two arcs match each other. Okay, this is a way of classifying them using that Venn diagram. And you can do that. It's kind of fun. But this is really what I wanted to get to because triangles are my favorite in all of this. And it says, name the polygon. If you don't know that this is a triangle, I'm going to sit here and cry. Are all the sides and all the angles congruent? Well, single tick, single tick, single tick. All the sides are congruent. Are all the angles congruent? Okay, the arc says that they are. Is the polygon a regular polygon? Think about that. If all the sides and all the angles match, is it regular? Yes. Here's the thing that makes triangles so cool. All triangles, no matter what kind they are, the interior angles, the angles we measure on the inside, have to add up to 180 degrees. That means without measuring, because they are telling me that these three angles are the same, if I do 180 divided evenly between these three angles, every one of those is a 60-degree angle. And a triangle with equal sides and equal angles is going to be called an equilateral triangle, an equal sides triangle. I want to do the geometry section kind of slowly because I want you to be able to enjoy it and really get it. So this says name each polygon, then tell whether it is a regular polygon or not a regular polygon. Are all the sides and the angles the same here? Yes or no? Are all the sides and the angles the same here on number 3? Yes or no? What about number 4? Okay, you're going to be asked to do this on the worksheet. And here's the on your own section. I'm looking at the tick marks, and that's telling me something. I'm looking at that little cheat code that shows this is a perfect right angle. They didn't use an arc on this one. They're using that little square mark to show you that it's a perfect right angle. That means 90 degrees for every one of those corners. If we look at this one, we can see that these two are the same, and this one is an acute angle. Do these match? What about these? You'll be doing this on the worksheet, so I hope you're paying attention. The worksheet will be numbered 1 through 8, and you will need to answer if it's regular or not regular. I would pause this video. I would look at this. Actually, it'll be numbered 2 through 8. I would look at this for the first 3, 2, 3, 4, 5, 6, 7, 8. Are they regular or not regular, and why?